Now I am. Thank you. Did your job. Okay, so our goal here, right, if we're supposed to write this thing in slope-intercept form, we're going to write this in the form y equals mx plus b. So essentially, what do we need to do? We need to find slope and y-intercept. We need to fill in the values of the parameters, right? They haven't given us any of those directly, but they've given us enough information to find them, right? To find one of them, to calculate one directly. So what is that? Slope. What's the quotient I'm going to create to find slope here? Okay, so y2 minus y1 over x2 minus x1. And what are those numbers?
10, negative 10,
Minus -6, so plus 6 over plus 6. Okay, so that gives us, what, -4/8. Okay, so we're halfway there. So we know what m is. And then the way we talked about this, from there, what could we do? Okay, so now we're trying to find b, right? That's the one parameter that we're missing. But to find that, we can use a solution of the equation to solve for b, right? So we could pick either one of these, it doesn't matter. Let's just say we use this one, right? So if I'm going to plug in those values of x and y, I get -6 equals -1/2 times -6 plus b. And I can use that information to solve for b. And then once I know the values of both parameters and I have fit the function correctly, right? So this is just real quick, what do we get? If I simplify, I'm going to get a 3 there, right? If I subtract the 3 to this side, what am I going to end up with? So we know b, we know m, so our line looks like y equals -1/2 x minus 9. Right? Make sense? Okay, we can do the same kind of stuff with other functions. And that's the topic of the day. It's how do we fit harder functions, quadratics in this case. So this time we want to try to write the quadratic function in its factored form for the parabola that passes through those 3 points. Okay, now you got to stare at those 3 points for a second and tell me there's some coded information there. What are they telling us? What are they telling us? It's sideways, meaning the parabola's going like this? No, it's going to be a regular parabola. But 2 of these 3 points, there's something special about 2 of those 3 points. They're zeros. They're zeros, right? Okay, they're zeros. So if the y values are 0, what does that tell you about those points? They're zeros. What's another name for real zeros? Well, true. But in terms of a graph, what are they? X-intercepts, right? So they're giving us the values of p and q, aren't they? Right? This is telling us right here that p is -5, and this is telling us that q equals 7, right? So they're giving us 2 of the 3 right away. So the only one that we're missing is a, right? And that's what makes this problem pretty easy to do. So right away we can say this. We can say that f of x equals a times x minus -5 times x minus 7, right? So that's all I've got to do is find a. Suggestions about how I could find a. Okay, put a point in there. So could I, how about like this guy right here? Is that going to work? Okay. It's not going to work. And we can see that it's not. If I try to plug in the point 70, I'm going to, so look what will happen. I'm going to end up getting, this is just y, right? So I'm going to get 0 equals a times x plus 5 times 7 minus 7. Well, duh. I mean, anything times 0 is 0. That didn't help us, right? So there's an important lesson to be learned here. We've already used those 2 points to give us these 2 parameters, right? If we want to find the other parameter, we have to use a different point because we've already used this information, right?
13.
So we got to use this guy right here, right? We got to use the other point. So 1354, we can use that one to find A, right? So what happens then? If we use that solution, I'm going to get 54 equals A times 13 plus 5 times 13 minus 7. And that's pretty easy to deal with now, right? I'm just solving. I've got one equation, one variable, no big deal. 13 plus 5 is 18. 13 minus 7 is 6. 18 times 6 is what, 108? So I end up with 54 equals 108A. So what do I get? 1/2. Yeah, if I divide each side through by 108, I end up with A equals 108. I've got A, I've got P, I've got Q, and so my answer just looks like, oh, whoops, A equals 1/2. What am I saying?
How do you do that?
I don't know, that's interesting math there. And so I end up with 1/2 times x plus 5 times x minus 7. Okay? So I needed, now notice that when I did a line, when I fit a line, I needed 2 points, right? When I fit a parabola, I needed 3 points. This is another point that we'll come back to later in the year, but we can already start to talk about this. So you've talked about this for probably 3 years now. How many points are required to define a unique line? 2, right? 2 points defines the line. That's all I need. If I get 2 points, that's all the information I need to either graph or write the equation for a line, right? So how many points are required to fit a unique parabola? Quadratic. 3. It takes 3. 2's not enough, right? It takes 3 points to define a parabola. If we jumped up from a quadratic, what about the next level up? What if we pick like a cubic function? How many points do you think we're going to need? 4. If we pick a quartic function, where it's next to the 4th function, how many do you think we're going to need? Etc., right? Okay, so how about something like that? That looks like I'm cheating though, doesn't it? So now we're going to do the same kind of thing, only we're going to write this quadratic function in its vertex form, but I only gave you 2 points. How does that work? I mean, why? I just told you need 3. Did I lie to you? I mean, I didn't really lie to you, but one of these points is a special point. It sort of counts as 2. The vertex, yeah. So the vertex counts as 2. And here's a way you can sort of conceptualize why the vertex counts as 2.
You just go through the 1 and then go to the opposite.
You go to the on the other side.
Right, exactly. So if we're going to graph a parabola,
I don't know if the vertex.
I told it to you. I said it's the vertex. Right. So if we graph a parabola, the parabola has folding symmetry about the vertical line through its vertex, right? So we know, for example, that if I have a point here and I know where the vertex is, that implies automatically I know there's going to be a second point over there, right? These are always going to come in pairs. So if I knew where the vertex was, knowing the coordinates of that point would allow me to say, okay, from the vertex I went over so far and up so far, I could just go back that same distance, right, and up the same amount, right? So these always come in pairs. Think of these as being, let's say these are like reflections of a bead that I'm sliding along this parabola. Say I bend a wire in the shape of a parabola, and I'm going to put a mirror up here. And as I slide this bead along that wire, I'm going to see the reflection on the other side of the parabola. You kind of get what I'm saying? Okay, what happens though if I slide that bead, if I slide it all the way down here to the vertex?
It's on the vertex.
The reflection of the point on the vertex is itself, right?
Yeah.
So can you see there that by the symmetry of the parabola, the vertex has the properties of really being 2 points in one? Because both of these mirror image points are just superimposed on the same point, right? So that's one way to think about it. That's one way to sort of justify why we can cheat on this one. Why we're able to say, I'm only giving you 2 points. There's another way too, though. How many parameters are there in a quadratic function? If we look at all of our quadratic functions, general form, vertex form, or factored form, how many letters show up in each of those? How many parameters do we have to fill in? 3, right? We have to always fill in 3. So as long as we can fill in those 3 parameters, we're good. Well, the trick is the vertex accounts for how many? 2, right? It's giving us h and k in that 1 point, and so therefore we only need that one, as long as we know it's the vertex. Now, if I didn't tell you it was the vertex, if I just told you it was a point, you couldn't do the problem, right? Because then, if you don't know that that's the vertex, you just think it's a point, then I've only given you essentially 2 points, and that's not enough to fill in 3 parameters. But the fact that I gave you the word vertex with that, that's the extra information that almost counts as a separate point, right? So because this is the vertex, it's telling us h equals -5, k equals 16. So this ends up being an easier problem, doesn't it? So we end up then with, if we plug those in, we end up with f of x equals a, I'm able to fill in those two, times x minus -5 squared plus 16. I've only got one unknown left to find, and so I only need one other point, and there it is, right? So if I plug those values in, if I use that solution, I'm fine. I end up with -48 equals a times -13 plus 5 squared plus 16, solve for a. Okay, so what's -13 plus 5? Squared? 64. So I get -48 equals 64a plus 16. If I subtract 16 from both sides, I get what? -64 equals 64a. So I got a, I've got h, I've got k. So there's my answer. Okay? No big deal, right? Those are those are easy to do because we picked convenient forms of the quadratic function where the points directly gave us parameters. Like in this case, the vertex directly gave us h and k. In this case, giving us the x-intercepts told us p and q without doing any work at all. Okay? How about that one? So this time we want to put it directly into general form or standard form. And they give us 3 random points. Do those points tell you any of the values of a or b or c?
No.
They don't. So this ends up being a harder problem. Right? In this case, we've got to find the values of a and b and c. So we've got 3 parameters whose values we need to find to be able to fit this curve, right? So essentially, those are 3 unknowns, right? We have 3 points. These are solutions, right? They're points that sit on our function, and so they're values of x and y that have to satisfy the original equation, right? So we can plug those in for x and y, but when we do that, in each case, we're still going to end up with a and b and c in each of those equations. I'll kind of let's go through this, and you'll see what I mean. Let's take the first point. So if we take this first point, x is 2 and y is -3, and I plug that into my function, what am I going to get? So we're starting with, let me write the function down so we can just kind of line them up vertically. So f of x equals ax squared plus bx plus c. Okay? Time. Focus. So what do we get if I use that point as a solution? -3 is my y value, right? Equals a times 2 squared, so 4a, right? Plus b times 2 is 2b plus c, right? Okay. What if we use this point?
Make 6 equals 9a
Right? A times 3 squared, so that's 9a
plus 3b
plus 3b
plus c.
plus c.
Okay.
Okay?
Next.
And let's use this one.
Equals 15a plus 4b plus
Okay? So I've got how many equations there? 3 equations. How many unknowns?
3.
3.
Oh.
Are those linear equations?
Yeah. No.
They are, right? But remember, this is, how come they're linear? They don't, is the graph of that a line? No, it's not. The graph of that is going to be a plane, right? Where we've got the a-axis and the b-axis and the c-axis. So it's going to give us a plane. This is the stuff we talked about. It's been a while ago with all our, snow days and stuff, but it's a linear equation because each of the variables is taken to the first power, right? And none of them are multiplied by each other, right? So it's a matrix deal, isn't it? This is a 3 by 3 linear system, right? So all I've got to do with this is let's just take this whole thing and let's just write this as a grid. We're going to write this as a 3 by 3 linear system, right? Where we've got the 3 variables a, b, and c. And if we're going to put these into each of these equations, we need to write in standard form. We need to write linear equations in standard form. So that means we're just going to arrange the coefficients in alphabetical order. So we end up with this first one is 4a plus 2b plus c equals, and then we're going to put the constant on the right side. Equals -3. This one becomes, becomes 9a plus 3b plus c equals -6. 16a plus 4b plus c equals -11. So there's our linear system, and we'll have to use a calculator for this.
Oh no, you blocked it. Oh no.
Okay, so I'm still. There we go. Okay, so now this is kind of nice. I'm still stuck. This is from last week. I'm still stuck in the, or maybe it was this week. I can't even remember. I'm still stuck in the inequality function that I was in last week. So it used to be that you had to go all the way into apps and you had to go to the menu and then hit quit app. All you have to do now with the new version of this is just go over to quit app and hit enter. That's kind of nice. And then I choose number 2. Okay, so now I'm out of that and I can go directly into matrix stuff, right? So we go matrix. I'm going to use one of these 3 by 4, so I'll just use matrix D. I'll edit matrix D. So it's a 3 by 4. What are my coefficients? 4, 2, enter, 1, enter. There they are. Okay, so now what? Quit. Matrix. Math. Move up to RREF. matrix D, so 4. So what are my solutions? Yeah, let me do... Okay, just so I have everything on the notes, let me do this first. So I got D. Okay, so what's that telling us? What's that telling us when I get my answer here? So A equals -1, B is 2, C is -3, good. So our answer then just ends up looking like f of x equals -x squared plus 2x minus 3. Right? Okay. So could I have done these other equations the same way? Could I have used a matrix for like that one?
Probably.
Could have, but I just don't need to. Right? I could have done the same thing. I could have, if I wanted to put this directly into standard form, I could have done it that way, but probably it would have been easier, rather than going through that whole process, it probably would have been easier just to start off in factored form and then expand it out. Right? But I could have used the same trick. Could I have used the same trick there? No, I couldn't. That's one. How come I couldn't have done that one using the same trick? I only got 2 points, right? And there's no way to tell the calculator that that's a vertex. It just, when you put in a point, if I use a solution like that, it's not gonna solve it because it's just gonna be. You could, but that's a lot of work, right? Wouldn't it be easier just to, if I want to put this into general form, wouldn't it be easier to fit this, being as we know that's a vertex, it'd be easiest to fit this into vertex form and then just expand out vertex form, simplify it to put it in standard form or general form, right? That make sense? Okay. I don't have this assignment up yet. I gotta fix a problem. I just was building these problems and I got one I still have to fix. But you guys can work the rest of the period. How many people are done with everything? Okay, that's good. Okay. So if you're done with everything, you can work on other stuff. Otherwise, I'll put the rest. You can spend the rest of the period working on the old assignments, and I'll have this one up very shortly.